All right, Algebra 2, we're going to finish up 4.5 today, so we have fractions again. But this time it's not just x on the bottom, we have a full term. So we have x minus 3 over here, and then x squared minus 9 on the right side, which can factor down into x minus 3 and x plus 3. Let's find the least common denominator of these two denominators right here. So we need an x minus 3 to cover this fraction, so let's write that down. And then we've already written down one x minus 3, so we don't need to write another one. We can just use the same x minus 3 for both of these terms right here. But we do need an x plus 3, so our least common denominator is x minus 3x plus 3, which means that we have the restrictions, because the bottom of a fraction can't be 0, we have the restrictions of positive 3 and negative 3. And once we find the LCD, we're going to multiply that to the top of both fractions, as you can see in our work right here. Let's cancel out what's on the top and bottom, and then we are left with 10 times x plus 3, which you would just distribute, and that's what I did over here. And then 60 is by itself. Then we're going to do all this math, and we find out that x equals 3, but 3 is a restriction, so that's not a solution. So we have no solution for this problem. In our second example, we have two fractions and a whole number, which can be written over 1 if you want. And we still need to find the LCD, so we need an x plus 7. We wrote it down. We've already written down 1x plus 7, so we're good there. And 1 goes into anything, so our LCD is just x plus 7. Which means we have a restriction of negative 7, because that LCD can't be 0. And then we're going to take that least common denominator and multiply it to everything. So not just the two fractions, we have to multiply it to the whole number too. These are going to cancel, and then we distribute here with the 8, and we see that we have 23x equals x squared plus 8x plus 56. Let's move everything to the other side. So we're going to subtract a positive number, and we have 0. And when we have 0 on one side of a quadratic, we can factor it down and solve, and you can see that we have 8 and 7 as our answer. Neither of those are a restriction, so both of them are solutions. Last problem, we have a word problem here. So the speed of a stream or a river is 2 miles per hour. The boat travels 13 miles going upstream, so against the current, in the same exact time, that's important, that it takes to travel 17 miles going downstream or with the current. So when the river is pushing against us, we go 13 miles. When the river is pushing with us, we go 17 miles. And we want to find out the speed of the boat. So let's represent what we know with some variables. So our boat speed is S, or you might see R on Pearson. Same thing. When we go downstream, we're going faster because the river is pushing us at 2 miles per hour. So it's whatever speed we're going plus 2 miles an hour. When we're going upstream or against the current, we are going our speed, but then the river is slowing us down by 2 miles an hour. And then our time is the same always, because it takes us the same time to travel these two distances. So time is represented by t. Well, we know that time equals distance divided by speed. So let's write some equations. When we're going upstream, we go 13 miles going the speed of s minus 2 because we're going against the current. And then when we go downstream, it takes the same time, right? So t is the same. We go 17 miles with a faster speed. So since they have t in common, we can just take their right sides of the equations and set them up equal to each other, and then we are going to solve just like we did on either of these. So find the least common denominator, multiply them to the top, cross out what you know, and then just solve for the variable. And we see that the boat travels 15 miles an hour.